Hello everyone, hope all of you are doing great. And in today's video, we're going to discuss the lower and the upper bounds. Okay, just to remind you of an old concept that you already studied in year 8, how to round or how to find the lower and the upper bounds of a rounded number. So if I tell you that the number that is given is rounded to the nearest thousand, to find the lower bound, you need to minus 500, add 500. It is what? It's half step size. The step here is the nearest thousand to the half of it is 500. So you add and you minus 500 to find the lower and the upper bound. But if it's to the nearest hundred, the half of the step is 50. So the lower bound minus 50, upper bound add 50. Like for example, if I tell you 300 is rounded to the nearest hundreds, find the lower and the upper bounds. So it's 300 minus 50, 250. Upper bound, 300 plus 50, 350. The inequality, it is going to be x is greater than or equal to, because 200 is and 50 is included. You put before it here the lower bound, and right after it here, you put the upper bound, but it is not included. So this is how we write the error of the interval error. But here, make sure that you put the equal sign over here. It is x is greater than or equal to 250 and less than 350. All right. So until you reach the end, I'm gonna just minimize here the size of the page, just for you also to see it. And if you'd like to take a screenshot of it, here you go. The nearest thousandth, for example, you're going to find that I minus 0.005 and I add 0.005. So for example, this number is rounded to the nearest thousandth. So you're going to subtract for the lower bound this 5/10,000th, and you're going to add 5/10,000th, which is going to give you this value at the end. This is the upper bound, this is the lower bound, and here is the inequality. Okay, so you need to know this table very well, understand it. There is no need to memorize it at all. If you understand it very well, then you will be able to find the lower bound and the upper bound of whatever you need easily. And this is year 8 level. Okay, about that new level that we need to practice a little bit more, you got here the first question. This saying to you here, 3.52 is a number with 3 decimal places. Is a number with 3 decimal places, but rounded to the nearest hundredth. So it is originally a number with 3 decimal places, but it is rounded to the nearest hundredth. Find the lower and the upper bounds. Okay, Mr. The lower bound is actually what? 3.52, but I'm going to minus from it 0.005. If it is rounded to the nearest hundredth, then I need to add or subtract 0.005. You add for the upper bound, you subtract for the lower bound. So here it's lower bound, I'm going to subtract it. It is going to give you exactly 3.515. But if I wanted the upper bound, then you need to do 3.52, add to it 0.005, which is going to be equal to 3.525. This is the lower and the upper bounds of this number. Okay, the next example here says to you, 13.7 centimeters is a measurement that is rounded to the nearest millimeter, which is this one, here in the millimeter. Find the lower bound and the upper bound of this measurement. Okay, mister, for the lower bound, I'm going to do 13.7, but I will minus from it. It's rounded to the nearest tenth. No problem. Then I will minus 0.05. And if you wanted the upper bound, I'm going to do 13.7 plus 0.05. This one here will give you 13.65, while the other will give you 13.75. 13.75. While the other will give you 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75. 13.75 Next question, this saying to you 70 is a number that is rounded to two significant figures. Two significant figure, here is the first, here is the second, so it is rounded to the nearest whole number or rounded to the nearest ones. So it is, Mr. For the lower bound, it is actually 70 minus, it's rounded to the nearest ones, the nearest whole number, so it is minus half. And for the upper bound, it is 70 plus half, which is 70.5 here, 69.5 here. But in this question, they provided you with the same number, but they're saying it's rounded to one significant figure. One significant figure, it means it's rounded to the nearest tens. Here is the first significant figure. Rounded to the nearest tens? No problem. So the lower bound is 70 minus 5, and the upper bound is 70 plus 5. This is 65, and here is 75. Okay, this question here is a little bit different, and it's going to take us to the next level. But before heading into this question, I would like to remind you of something. If they said to you, for example, that's a different thing. It has nothing to do with question four. But if I say to you, it's rounded to the nearest 5 centimeters, for example. So I'm going to add and subtract what? Rounded to the nearest 5. I'm going to add 2.5. I'm going to subtract 2.5. Just to the half of the step. All right. Here, this saying to you, x plus y minus z. Mister, here I need to follow something that is extremely important. I need to know if I'm going to get the lower bound or the upper bound. They told you here they want the answer find the lower bound. So they want find here, they're saying what? The lower bound. But Mr. Will I get the lower bound of x, the lower bound of y, the lower bound of z? It depends. What do you mean, Mister? If you are adding it or multiplying it, you follow what they want. Like what? Like in x. It is being added, yes. So it is what? I'm going, Mister, to get the lower bound as they want. So I'm going to get the lower bound of this. Good. What about the y? It is added also here. So I'm going to get also the lower bound as they want. But if I'm minusing the z, as you see over here, you're minusing, oh, this is a problem here. Minus gets the opposite. So if you're minusing the z, I'm going to get the upper bound of the z. And if you're going to get here divided by y, okay, divided, also the same. It is the opposite, the same as subtraction. They wanted the lower bound, I'm going to get the upper bound. Where did the x go? I remember that I wrote here x. X. Okay, here, x. Oh, mister, the x, what happened to it? It got minused, so it's going to be the opposite. No. Why, mister? Because what happened to the x here is actually two things. It is in the denominator, which means division, and at the same time, subtraction. So both of them together as if they cancel each other. So it is division, mister, and subtraction at the same time? No, mister, keep it the same. Lower bound stays lower bound. Yeah, mister, it got subtracted. Not only subtracted, it got subtracted and also divided, so it remains the same. If it was subtraction only, get the opposite. Division only, get the opposite. Opposite, I mean, if they want lower bound, get the upper bound. If they want upper bound, get the lower bound. So if it's subtracted, get the opposite. If it's divided, get the opposite. Mister, if it is divided and it's both divided and subtracted, what am I going to do? Get the same as what they want. Okay, that's what happened here to the x. It got divided and subtracted at the same time, so we're gonna get the same like what they want. We're gonna get the lower bound. Write this down, write these notes down, study them because you're going to forget it very soon. So write it down, repeat it to yourself, explain it to yourself so that you don't forget it. And then in practice, in the practice or in doing the homework, you can get back to it. Or you can practice more in order to avoid forgetting the rule. Here, let's get back to answering the question. X, I want from the X the lower bound. The lower bound that is saying it's rounded to two significant figures. The lower bound is going to be minus. So here, the X is the lower bound of it. I'm going to write this now. Look at this. X. I'm going to get the lower bound and I'm going to get the upper bound. So lower bound is what? 4.45. This is the lower bound. Upper bound, it is 4.55. Upper bound. The Y, 22, rounded to the nearest whole number. Lower bound, 21.5 is the lower bound. 22.5 is the upper bound. Z, 5.62 rounded to decimal places, so it is 5.615 is the lower bound. 5.625 is the upper bound. This list is extremely important. Oh, Mister, you've taken so long to answer such a question. Oh, yeah, because I'm explaining it to you. You don't need to do any of that. You don't need to write this. You do not need to explain it to someone else in the question. All what you need to do is just to go write this right away. This and this. So these two steps are extremely important. The other one over here is not important at all. Now let's start. So here is first step. I need the pen now. This is the first. This is the second. Or you can do this is the first, this is the second. It doesn't actually matter. Now I need to substitute. X lower bound. Oh, Mister, is 4.45. 4.45 plus Y lower bound. It is 21.5 minus Z upper bound. Z upper bound. It is 5.2, 0.625, 5.625 over Y upper bound. Y upper bound is 22.5. Y, and then minus X lower bound, 4.45. You can put this on the calculator and it's going to give you the answer right away. Let's do it. Here we go, the fraction. In the numerator, 4.45 plus 21.5 minus 5.625. All is over 22.5 minus 4.45 equals SD. It gave you this, but you wanted your answer corrected to one decimal place, so it is 1.1. So the answer is 1.1. That is it. Next question. They say to you here, the distance is 42 kilometers, corrected to decimal, two significant figures. Speed is 96 kilometers per hour. Find the upper bound of the time spent in this trip. Give your answer correct to the nearest minute. Okay, let's do this. We remember, and you took this also in physics, you took it in math, that distance, we have a pyramid over here, and I got here speed, I got here time. They wanted the time, Mister, so it is distance over speed. So time equals distance over speed. The distance I need what? Oh, Mister, they want to find the upper bound of the time. So distance, I'm going to find that upper bound of the distance. What about the speed? Oh, the speed is here divided in the denominator. I'm going to find it the opposite of what they want, which is the lower bound of the speed. Good. Let's start. T equals. Here, the upper bound of the distance of 42 is going to be 42.5 over the lower bound of the speed is going to be 95.5. Let's do this on the calculator. T equals, here is the calculator, 42.5 over 95.5 equals SD. Oh, mister, but this is in what? In hours. So they need it in minutes. So multiply by 60 SD. So what is the time that is taken? Yes, exactly. It is 26 point what? Point 7, right? That is the time that is taken here in minutes. Good. So 26.7, but they want it to the nearest minute. So what is it going to be? 27 minutes exactly. So I'm going to write over here 27 minutes. Again, all what I've done is knowing that the time is equal to distance over speed. So distance over speed, I'm going to get the distance, the upper bound of the distance. And we found that the upper bound of the distance is what? Is 42. 0.5, while the lower bound of the speed, because it is being divided, so the lower bound of the speed is 95.5. Dividing both of them and multiplying the answer by 60, you're going to find that it is 27 minutes exactly. Volume of a cube is 36.74. They want you to find the lower bound of the surface area. Okay, Mr. Surface area equals what? The surface area of a cube, surface area of a cube equals, Mr. It is equal to side squared. Side squared is what? Imagine that this is here is a cube. Sorry, I need to erase this. Here I have a cube. All right. I'm gonna get what for the surface area? Surface area means add the area of all the six sides, all the six faces. So I need to get the area of one face, one square, which is s squared. Then you multiply by 6. Multiply the area of this square by 6. Done? Yes, I will be done. But Mister, I don't know the length of the side. The length of one side, I don't know it. No problem. I already know that the volume is what? Volume is s cubed. But if I want to find the side, so s equals the cube root. I'm going to send the cube to the other side, but it's going to be cube root of the volume. Okay, so s equals the cube root of the volume. What is the volume? 36.74 emitter. Okay, but remember, they want you to find the lower bound. So I went to the lower bound of this volume, which is rounded to decimal places. So it is 36.735. This is the length of one side. So surface area equals 6 multiplied by the side, which is cubic root of 36.735. All of this is squared, not the 6. So I'm going to go to my lovely calculator and right over here, 6, open the brackets, cubic root of 36.735, close the brackets, all is squared. The brackets, what's inside the brackets is squared, equals 66.303. A lot of numbers that they wanted the answer corrected to one decimal place. So it is 66.3. 66.3 66 66.3. They didn't give you here a unit, but usually they're going to give you a unit here, like, for example, centimeters cubed. And so I'm going to know that it's centimeters squared. That's the answer correct to one decimal place. Thank you so much, everyone, and see you in another video.